Lesson 12-7, surface area of pyramids and cones. So we're first going to define and identify what a regular pyramid is and a cone. So a pyramid or a regular pyramid is a pyramid whose base is a regular polygon. So it has to be a regular polygon. The lateral faces, which means the faces that are not the base, of a regular pyramid are congruent, so they're equal, isosceles triangles. So that means two of the sides of the triangle are the same, and they intersect at one vertex. That's what makes it a pyramid. And the altitude or the height of each face is called the slant height. So if you see the picture here at the bottom, we have a regular pyramid. You have the base, which looks like a square here. You have the lateral faces all around the outside are isosceles triangles. Two sides are the same and one side is different. And then the slant height is the height from the vertex down to the base on one of the lateral faces. And then to the right here is a picture of a net. So this is when you take the three-dimensional picture and you make it a two-dimensional object. So you draw what it would look like. And if you imagine folding this net up along the red lines, it would fold up to be a pyramid. So to find the lateral area of a pyramid, you want to find the sum of the areas of the lateral faces, which is all the triangles. So the equation for this would be L equals 4 times 1/2 SL. And what that means is that you have 4 triangles, and then you're basically doing 1/2 the base of the triangle times the height. But the reason that they put S and L in here is because when it's a pyramid, you're not multiplying it by the full base. You're multiplying it by one edge of the base. So we're going to actually think of this as half the edge of the base, and it's going to be times L, which is actually the slant height. So that's how you look at this for the lateral faces, which we know because you have to find the area of each lateral face. Well, the lateral faces are triangles, so you do 1/2 base times height, and then you have 4 of them, so you multiply it by 4. Now, you know that with the commutative property of multiplication, we can shuffle things around and still get the same answer. So what we're actually going to do is we are going to switch around some of our numbers so that it looks like lateral area equals 1/2 4 times the S, which we said was the edge of the base, times the L, which we said was the slant height. Well, 4 times the edge of the base is the perimeter. So that means that 1/2 times the perimeter times the slant height is your lateral faces. So this is actually the equation that you're going to want to memorize for lateral faces of a pyramid. So let's look at this example. Remember, our formula is L equals 1/2 P, which is the perimeter, times L. Well, the perimeter of the base is 20 because one of the edges is 4 and there are 5 of them. So 1/2 times 20 times 15. So I would leave the 1/2 and multiply the 20 times the 15 first, which is going to get you 300. And so the lateral area would be 150 centimeters squared. Now, just like we did in previous sections when we were finding the surface area of prisms, the lateral face is important. So the surface area formula is surface area sorry, let me move that. Surface area equals L plus B, which is the area of the base. And so for pyramids, our L is 1/2 the perimeter times the slant height plus big B, which is the area of the base. So with this same shape that we used to find the lateral area, we're going to find the surface area. So the surface area is the lateral area plus the area of the base. Well, we already know that the lateral area was 150, so we'll save ourselves some work. Plus, and they tell you that the area of the base is 29. So that means that you just add those together, and so you get 179 centimeters squared is the surface area of this object. So when we think of a cone, we typically think of an ice cream cone. Now, when you draw a cone, it's typically like a little bit of an oval on the bottom with the cone part sticking up. And then drawing the net of a cone is a little bit more difficult. You have your full circle, but then when you're drawing kind of the piece that sticks out, it's kind of like rounded, almost like a piece of pizza. So we don't really use the net of cones very often as an accurate way to demonstrate a cone. You just want to kind of memorize the formulas for this one, which are pretty easy. Lateral area is L is pi times radius L, where the L is the slant height, just like in pyramids, and radius is the radius of the circle. So let's look at this example to find the lateral area. We know that the formula is pi RL, so we have pi times R, which is 7.3, and the slant height is the 11.6, and when you multiply both of those together, you get approximately 266 as your, so this would be feet squared, as your lateral area. Now to find surface area of a cone, you're doing the same thing. You're taking the area of all the surface that you see. Well, because a cone, it only has one lateral face, and that is kind of the side of the cone. So then you're just adding in the area of a circle. So our formula for surface area is S equals L plus pi R squared, where L is that pi RL here. So let's find the surface area of this cone. The formula for surface area is big L plus pi R squared. We knew that our lateral area for this example was 266 plus pi. R is my 7.3 squared. So 266 plus pi times 11.6, and you get an answer of approximately 433.4 feet squared for my surface area. Pause the video to complete the lesson review. Make sure you show me this lesson review for verification of watching this video.